Okay, so we are finishing your notes on cross sections dx. So for third period, we kind of stopped before we got to any of the triangles. So we're going to do most of those today. So if you will, please turn to this example. Okay, we skipped equilateral triangles, but let's just kind of remember what we've already done. So we had already set up the graph. As you can see here, we already found the intersections by setting them equal. We found these 2 points here and here. Okay, so then we wrote our base. Remember, it was top minus bottom. And then we simplified it to kind of give us an easier expression to use as our base. So now we are coming down to write the area formula for an equilateral triangle. So remember, as we talked about in class, okay, the area of a triangle is still 1/2 base times height. Okay, the problem is that it's an equilateral triangle. So what that means is that this bottom side is the base, and then all of these sides are equal to each other. So the question is, how do I figure out what the height is? Because that's what I need to put, well, my triangle's kind of jacked up, but you get the idea. Okay, I need to know what is the height here so that I can figure out what to plug in here in my equation. So what I'm going to do is I'm going to take this big triangle and I'm going to cut it off to only look at one side. Now remember, we want the area of the whole triangle, but I'm going to break off this other side and pretend it's not there just to make the height one of the sides. So if I'm looking at half of my triangle, okay, let's talk about something for a second. First thing is that if this is equilateral, it also has to be what's called equiangular. And what that means is that all three of your sides have to equal each other. So think about if all of the sides in the triangle have to add up to 180, and I divide that into 3 equal angles, that means that each of these is going to be 60 degrees. Okay, so this side down here is 60 degrees. Now, the top side of this was 60, but I just spliced it in half. So that top side is going to be 30. And if that's a 30 and that's a 60, then the other side is a 90. So from here, I need to think about what the sides of my triangle are. Now remember that this side is the base. Okay, that's all the way across here. So then if it's equilateral, that means that this side is also the base. Okay, so think about that for a second. Now let's talk about if that's the longest side, well then what's this little short side? It has to be base over 2, right? Because this side is always double what the short side is. And then if this side is base over 2, then this side has to be base over 2 root 3. So then from here I can say, okay, well then that is going to be my substitute for the height of my big triangle. So I'm going to come back over here to my formula and I'm going to say, okay, area equals 1/2 base. And then instead of my height, I'm going to use this substitute here, b over 2 root 3. Okay? And then I'm going to reduce that to be like, okay, well really that's the same as 1/2 times 1/2 is 1/4. And then if I have this square root, I'm just going to put that on the top. And then if I have a b times a b, that's really a b squared. So remember, you want to try to condense that area formula just to make it look prettier before you put it into your integral. So then I would say, okay, well then a of x is going to be root 3 over 4, and then my base, which was the negative x squared plus x plus 2. And then that would have a squared as well. And then remember that if this is area, in order for me to get to volume, I just have to make it an integral. I'm going to put the root 3 over 4 on the outside, but remember that you could put it on the inside if you wanted to. And then that would be from, if you remember, my endpoints were -1 and 2, just like they were on all the other ones. Okay? And that would give you the volume of that shape. Which, again, not super important that you can visualize that. More important, really, just that you understand how to find the volumes. Okay? Go ahead and let's look at number 2. So we skipped this one yesterday, then we'll finish out number 3 afterwards. So up here at the top, my function is x squared plus 2x. Now, you should know that that's a graph that opens up. Okay, we know it's a parabola. The problem is that it doesn't have a y-intercept. That means that we know it's going to cross at 0. So the question is, does it cross over here? Does it cross over here? We don't really know. So what I'm going to do is I'm going to find the x-intercepts of my parabola. Remember, to find x-intercepts, you set it equal to 0. So if I do x squared plus 2x and I set that equal to 0, I'm going to factor out an x. That's going to give me x plus 2 left over, which means that my x-intercepts are at 0 and negative 2. So I already knew the 0 one, but then my other one is back here at negative 2. Okay, and then here's my graph. So we know it opens up. Okay? Now, look what it says. I want the volume, and I want the base to be bounded by that and the x-axis. So that means that I need to stay right here in my graph. Okay, then it also says that I want my cross sections to be taken perpendicular to the x-axis. So when I draw them in, that means that they're going to have to be top to bottom, just like that. So I'm going to come over here and I'm going to write my base equals top minus bottom. So then my base is going to be, the top is 0 minus the bottom. Now remember, why is it 0? Well, because the top is the x-axis. So then really my base is just going to be negative x squared minus 2x. That's my base substitute. Okay, let's look at part A. I want squares. Area of a square is b squared, which means that a of x would be negative x squared minus 2x squared. So I would take whatever my base is, the distance across my base, and I would square it. Okay, then from there I'd turn that into a volume. Negative x squared minus 2x squared dx from negative 2 to 0. Now remember that negative 2 is my x value here, 0 is my x value there. So that's how I got those numbers, or that those are the ends of my area, of my region. Okay, next one, I want a rectangle. So that's going to be base times height. But then notice what it tells me about the height. The height needs to be 3 times the length of the base. Okay, well then I need my height to be 3 times the base. Okay, well I can easily reduce that to just be 3b squared. And then from there, I'm going to write my volume. Negative 2 to 0, 3, and then b squared dx. Now remember, it is also an option that you can take that 3 and just put it in the front. Totally fine if you want to do that, totally fine if you do not want to do that, doesn't matter. Okay, come down to your equilateral triangles, letter C. Okay, equilateral triangle. Remember, we did this one. I'm going to do it one more time for you because I don't want you to just copy the formula. I want you to understand where it comes from. So here's my equilateral triangle. We know area is 1/2 base times height. Remember that this is the base. So the question is, how do I find the height? Okay, so remember that just like we did last time, if it's equilateral, that means that it's also equiangular. So all these sides have to be 60, which means that if I break a piece of that off, I'm going to break this side off this time. Okay, and I look only at that one side. Okay, this top triangle corner, this was 60, well now it's 30. This one is 60, that makes this one 90. And then if it's equiangular, if this is the base all the way across, then that means that this is the base. And remember, the ratio of a 30, 60, 90 is that if this is the base, then this is the base over 2, because the hypotenuse is always double the shorter side, which makes this side base over 2 root 3. And so then I'm going to come back up here and I'm going to use that as my substitute for height, because that's how tall an equilateral triangle is. So it'll be area equals 1/2 base times root 3 over 2 base. And notice that these are actually the same. I'm just kind of organizing it differently. Okay, but those are the same. Then from there, I'm going to combine my fraction parts. Root 3 times 1 is a root 3. 2 times 2 on the bottom is a 4 on the bottom, and then a b squared. So my volume equals integral negative 2 to 0. And then I'm going to put the root 3 over 4 here, b squared here, dx, where my b is negative x squared minus 2x. Okay, then you would type that into the calculator. That would give you your area. Okay? Now, take a look at the next one. This one says that I want an isosceles right triangle with the hypotenuse as the base of the cross section. So if I want the hypotenuse to be the base, okay, then this is the hypotenuse right here. Now, think about for me, if it's isosceles, that still means that these two sides match each other. So that still means that these two angles match each other. It's this angle, the 90-degree angle, that's always opposite the hypotenuse. So we're going to use the exact same skill that we used on the other right triangle now with this one. So first thing I'm going to write down is that the area of a triangle is still 1/2 base times height. But now I'm going to draw in the height, which I actually already did. It's right here. This is my h. And so I want to know, what can I call this height? Well, let's look at only one side of the triangle. So I'm going to basically pretend that this side is not there at all. So if I break up only that right side, remember that this is a 90, these were 45s. Well, then this is still a 45, but this 91 up here is now cut in half. Well, now that's a 45. And if these are both 45, then that's a right angle. Then I have that same kind of special whatever relationship that 45, 45, 90s always have. Now, what's different here, okay, is that this time I know that the hypotenuse is the base of my region. It's this base. When I say that, I mean this up here. So if this is my base across the bottom, then this would only be half of the base. Okay, well remember that if this is half of the base, then this has to be half of the base, because these are the legs of my triangle. So that's a half base. And then remember that if this is x and x, then this is x root 2. So it'd be a half b root 2. So then I'm going to come up here to my area formula, and I'm going to adjust it and plug it in. So it'll be area equals 1/2. My base is still going to be all the way across, but then for my height, I'm going to substitute this in. So it'll be root 2 over 2 times b. I'm videoing y'all's class notes now. I'll just bring it down to you. I don't want you to feel like you have to keep coming back up here. Okay, so then half times root 2 over 2 is going to be root 2 over 4. And then b times b is still b squared. So you'll notice that I still end up with kind of a weird variation of your area formula, but it's just using those special rights. So then my volume equals negative 2 to 0, root 2 over 4, b, oh crap, not b, it would be negative x squared minus 2x squared dx. And so that would be your answer. Okay, this is a parentheses pretend. Okay. All right, next one is a semicircle. Okay, so a semicircle is going to be like this. So this is my base all the way across. So then if I only want area for a semicircle, that's pi r squared with a half in the front. So then my semicircle needs a radius measurement. So instead of me trying to rewrite the height of the triangle, I'm going to try to rewrite the base. Okay, well think about it. If the base is all the way across, that's basically the diameter. Basically, get it? Okay, then the radius is just going to be half of that. So my r is going to be b over 2. okay, for this little piece right here. So then I'm going to come over here and I'm going to say, okay, 1/2 pi, my r is b over 2 squared. And then I'm going to square this piece and try to make it a little bit prettier. So I have 1/2 pi, and then when I square that, that's going to be b squared on top and a 4 on the bottom, because I had to do 2 squared. Then from there, I'll multiply all this constant stuff together. So across the top, 1 times pi is just a pi. And then 2 times 4 on the bottom is an 8, b squared. And then remember from there, that's my area still. So for me to get to volume, I need to turn it into an integral. So it'll be pi over 8. My endpoints were -2 to 0. And then I would put my b squared, which would be -x squared minus 2x squared dx. And then from there, you'd just be typing that in. Also remember, this pi over 8 could be on the inside. It really doesn't matter. I'm going to write it on the outside, but you should be kind of used to both. Okay? Next one is a semi-ellipse. Remember that an ellipse is the same as an oval. Okay, and your area for an ellipse is 1/2 pi j k. Remember that j is going to be your radius one direction, and then k is going to be your radius going the other direction. Okay, so let's think about for a second here. It tells me that the height is 6, so I automatically know that that side is 6. The question is, what do I put here? Okay, well, think about it. If the whole thing is the base, as per the usual, okay, the bottom of your shape is the base, then that means that half of it, remember, because this is kind of like a radius, would be b over 2. So this is going to be b over 2. Okay, well, let's rewrite our formula. It's going to be 1/2 pi. And then remember, j and k are just multiplying these bases. So I'll do b over 2 times 6. Okay, well, let's multiply that whole thing out. So across the top, I have 1 times 6 is 6. 2 times 2 is 4. Then I still have my pi and I have my b. Now, you can reduce that if you want to, but you don't have to. Then volume equals the integral -2 to 0. I'm going to go ahead and reduce it, I guess, but you don't have to. It'd be 3/2 pi, and then my base is -x squared minus 2x dx. Notice that that one did not end up with a b squared in it because your horizontal radius had a b in it, but your vertical radius was a constant because it told you that the height was 6. Okay? All right, turn over to that next page, please. All right, we have one left to finish. Notice we did a lot of the setup for this in class. Okay, so we shaded our region, we found our base, which is over here. Okay, we found our endpoints, -2 and 2. So really, we just skipped a couple of these shapes. So the first one was a semicircle. I'm going to go ahead and redraw this out. Explain it one more time, see if we can get it. So remember, for a semicircle, it's 1/2 pi r squared. But then remember that my base is all the way across. Well, then my radius will only be halfway across. So my radius is going to be b over 2, or a half of b. So then when I take that and plug it in here, I'm going to rewrite my equation as 1/2 pi b over 2 squared. Then remember that when I do the 2 squared here on the bottom, that's going to become a 4. Then 4 times this 2 is going to become an 8. So it's pi over 8b squared. Then remember, I already found my b earlier. So it'd be pi 8ths integral. That's supposed to be a pi. Okay, and then your endpoints were from -2 to 2. And then your base squared would be -3x squared plus 12 squared dx. Okay? All right, look at part D. It says a semi-ellipse whose height is 4. Okay, well think about, here's my ellipse. Height is 4. Well then all the way across is going to be my base. Well then my radius measurement, because remember you're always only taking half of it, would be b over 2. And that would be like in your equation, I forgot to write it, but remember for an ellipse it's 1/2 pi jk, where my j will be this side, my k will be this side. And if you reverse those, remember it doesn't matter, you're just multiplying the two radius measurements together. So it'd be 1/2 pi, my j is a 4, my k is a b over 2. Okay, we'll then multiply the bottoms together. 2 times 2 gives you a 4, but then I have a 4 on top as well. So I would have 4 over 4 pi times b, and then I'm just going to cross the 4's out. Because remember, my half and my other half are a 4 on the bottom, and then I had a 4 on the top from the height. So then volume equals pi b. -2 to 2. Okay? Alright, last one we are doing is equilateral triangles. Okay, so remember equilateral triangles are also equiangular. So if this is my base, this is my height, and then remember that that makes this my base, which makes this b over 2, which makes this b over 2 root 3. Okay, and I know I wrote that really small, but hopefully you can still see it. So then when I do my area, it's 1/2 base times height, but then I'm subbing out my height for my b over 2 root 3. Combine your b's, that's going to be a b squared. Combine your numeric pieces, a half times another half is a 4th, and then my root 3 will stay on top. And then from there my volume is going to equal root 3 over 4. B squared is -3x squared plus 12 dx. And then remember that your endpoints were -2 and 2. Okay? So go ahead and pull out your homework. I'll set up maybe like 1 or 2 of those just to kind of get you started. And then for the rest of class, I would like for you to get some work done on this. To make sure that you understand what you're doing. So take a second for me and set up, let's do number 2. Number 2. So it says that your region is going to be y equals 2 and square root x. So y equals 2 is going to be a flat line across. And then square root x, as you know, looks like that. So then if I want to stay between those, notice that it also gives me the qualifier that I need to stay in the first quadrant. So that's going to be this region right here. I have to stay between the graphs, but I also have to stay in the first quadrant. So this side is going to be x equals 0, and then this side I'm going to have to find by setting them equal to each other. So if I let root x equal 2 and I square both sides, then x is going to be 4. Okay? Then remember, I want to stay perpendicular to the x-axis. Okay, that's what it says here and here. And this one says perpendicular to the y-axis. See the little star? You're not going to do that one, so don't do that one yet. Okay, so I'm going to draw in my axis here, or my base here. And remember that base is always top minus bottom. So in this case, the top function is the constant 2, minus the bottom function is square root x. So its top is 2, bottom is square root x. That's my base. Okay, next one says I want to be a square. Well, then area equals base squared, which means that volume equals the integral of base squared dx. And then remember that my base is this, so 2 minus root x. Then remember that my endpoints are the x's of my graph, which would be from 0 till 4. So 0, 4, boom, you're done. Okay, go down to part C. I want an isosceles right triangle with a leg in the region. So remember that if it's a triangle, then it has to be 1/2 base times height. But then it's saying that I want a leg in the region. That means that one of your legs has to be down. So these two match each other. Okay, well then think about if it's isosceles, what that means is that two of your sides have to match. So if this is my base, then my height has to also be my base. So I'm going to rewrite this as 1/2 base squared. And remember, I can only do that in this case because it's isosceles, so the base and the height match. Well, then volume equals the integral from 0 to 4, because those are still my endpoints. And then remember, you can put the half inside or outside, it doesn't matter. And then your base is 2 minus root x squared dx. Okay. All right, why don't you set up number 1 and then see if you can do all the parts of those, and then I'll send that one out on Remind 101 for you to check it. Okay? So your goal is to get most of this homework finished. All of the ones that say this, if it says perpendicular to the y-axis, those are going to be dy, and so I don't want you to do those yet. Okay, you're going to need to have tomorrow's notes to be able to do those. Okay. So for example, this one too says y-axis, and then y-axis. So you can't do any of that last page, but it looks like this whole page you could still do. Okay, because look here, it says x-axis, 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 and x-axis. Okay? And then I guess let's do one of those just to make sure that you know how to type these into the calculator. So let's just say we're doing number 6. Okay, so your equation is y equals inverse tan x. Now remember that if you have a calculator, don't try to graph it by hand, just do it in here. So inverse tan x looks like that. Okay, and then my other equation is y equals 3. So I'm going to graph those on here. So y equals tan x, y equals 3. Okay, there's inverse tan x. There's y equals 3. So I'm going to sketch that now onto my paper. So it looks like it goes like that. Okay, and then y equals 3 was up here. Okay, now look where it tells me that I want to be. It says in the first quadrant. So that means I'm going to start at 0. And then it tells me to shade until x equals 1. Now, my calculator is not going to put that on my screen for me. But we know that it's a vertical line, so we can draw it in ourselves. That's x equals 1. So I'm going from x equals 0 to x equals 1. Those are going to be my boundaries. Okay, next thing I need to do is draw in my base. Remember that I want to be perpendicular to the x-axis. I draw it in. That means that it's top minus bottom. So my base is going to be the line, which was y equals 3, minus the squiggly curve, which was inverse tan x. So that's my base right there. Okay, then from there, I'm going to write my equation for my shape. So it tells me that I want the cross sections perpendicular to the x-axis. It says it is a square. So then remember that area of a square is b squared. Then I'll plug this in and turn it into an integral. So volume equals the integral of, my base is 3 minus inverse tan x squared dx. And then my endpoints here would be from 0 till 1. Okay? Now, as far as putting this into the calculator, okay, you're going to hit Math 9. So I'm going to get out of this mode and just go into my normal mode. Second quit. Go into Math 9. And then I'll go from 0 to 1 are my endpoints. And then in here, I'm going to do parentheses, y2 minus y1 squared dx. Now, obviously you could go through and write in 3 as your y2, inverse tan x as your y1, but especially if the equations are a little bit longer, then it's easy to use those shortcuts. So I got 6.612, which is the same as answer choice B. Okay. All right, good luck. You can do it. You have 20 minutes to get some work done.